What is generative AI? Generative AI is a category of artificial intelligence that creates new content based on patterns and relationships learned from large sets of data. And while you may be more familiar with large language models like ChatGPT capable of generating text, this type of AI can also generate images, video, music, and code, with new types of outputs continuing to be developed. Applications of generative AI are also growing quickly. You may have noticed some generative AI features popping up in some of the tools or sites you use on a regular basis. These features are also popping up in educational technology designed for teaching and learning. But these specific tools are not the only way that generative AI is entering the classroom. From primary schools to institutes of higher education, instructors are grappling with how to best leverage the potential applications of tools like ChatGPT for teaching and learning, and how to ward off their pitfalls. And in order to make a wise decision about how and where to incorporate generative AI into your teaching practice, it's important to have an idea of how this type of AI works. Let's take a closer look at the mechanics of generative AI tools. Generative AI is trained on large sets of data. When we use the term data, what we're really talking about is any type of content published online. We call this data training data. Generative AI uses a large set of training data to train what is called a model. During training, the AI identifies patterns, structures, and relationships within the data to create a kind of map. This map is the model. Once it's trained, the model can then generate new content based off what it has learned. Let's imagine the training data includes a multitude of text entries. As the model analyzes the text, it identifies relationships between words based on how frequently they appear together and in what contexts. For instance, the model might learn that the phrase "good night" is often followed by "sleep tight" in the context of a bedtime story. As the model analyzes many bedtime stories, it will also recognize common elements, structures, and themes used in the genre. This helps the model create a template or guideline for what a bedtime story might look like. Now that the model is trained, it's time to enter a prompt. Let's say we input the prompt, "Write me a bedtime story about an ice skating unicorn in New York City." The model will first break down the elements in the prompt and try to understand their role and meaning based on the relationship to other elements. It might recognize New York City as a location or setting for the story. It might identify the meaning of "about" here to indicate the topic of the bedtime story. It might recognize ice skating as a skill possessed by the unicorn. The model will also pull in information it knows about each word, including real-world knowledge and what it knows about each word in context. New York City is a bustling city with lots of tall buildings and lights. A common place to ice skate in New York City is Rockefeller Center. Bedtime stories are often short, include simple language, and have a happy ending. So, based on all these connections, it will generate a new bedtime story that is similar in some ways to training data. So let's recap what just happened here. The model has 1. Broken down the prompt into separate elements, 2. Used its training data to discern the relationships between these elements, and 3. Generated new content based on these relationships and on the type of output requested. Now we have new content that is similar in many ways to human-generated content. So similar that on first glance it might even fool us. But while it appears human-like, it is not the same as human thinking, as it pulls from the most common connections it finds in a limited set of data. And all this means that what these AI tools produce is inherently derivative, which may run counter to your goals if you're hoping to produce original content. An AI-generated bedtime story, for example, will almost always begin with "once upon a time." It might also run the risk of reproducing cultural biases that are reflected in the model's training data. Still, these tools are hugely powerful and can be useful thought partners when originality is not the main goal. And we'll continue to get more and more mileage out of these human-AI collaborations the more we advance our prompting capabilities. So far, we've just explored how a text input can generate a text output. But a text input can also generate an image or an audio output. And thanks to new models, we can go image to text, image to image, audio to text, or audio to blend shape for 3D animation. We're even seeing the development of multimodal generative AI models that can be prompted with more than one mode of input. All of these different types of generative AI models have the potential to unsettle the practices of teaching and learning by offering us new tools for problem solving, new content to analyze, and finally, and perhaps most impactfully, new ways to create.